Hello everyone, welcome back to my channel Learn Math with Priya. In this video, we are going to discuss 21 to 25 questions from section B, which carries 2 marks. Let us start with the 21st question. If you have not subscribed to my channel, please do subscribe so that you will get the notification whenever I post a new video. All the best for your board examination. Question number 21. In the given figure, find the value of x in terms of a, b, and c. So I have to represent x in terms of a, b, and c. First, let me consider the two triangle KNP and triangle KLM. So here I know angle K is equal to angle K because it is a common vertex, and angle PNK is equal to angle LMN. If the corresponding angles are equal, I can specify PN is going to be parallel to LM, isn't it? So I'm just filtering all the criteria from the given figure. So as per angle criteria, I can say triangle KNP is similar to triangle KML, isn't it? So now I can write the ratios as Kn by Km is equal to Pn by Lm. I already added the length of Km as B plus C because I can substitute in Km. What is Kn? Kn is C and Km is the total length, that is B plus C, is equal to Pn is X and Lm is A. Now I am just taking A to the other side because I need only X. So which is AC by B plus C is equal to X. Now I represented x in terms of a, b and c. Question number 22. Xy and mn are tangents drawn at endpoints of a diameter. First write the given. Xy is a tangent to a circle, isn't it? And it touches at a point D. So you have to write xy is a tangent to a circle at point D. So I know OD is perpendicular to XY because radius will always be perpendicular to the tangent. We know that theorem, right? Hence, angle EDY will be 90 degree. So this angle will be 90 degree. Similarly, the other side also, isn't it? Now I am considering MN. MN is also another tangent to a circle at a point E, isn't it? So I'm writing this, and from here I can understand again OE is a radius which is perpendicular to MN. Why it is so? Because radius is perpendicular to tangent. So now I can say OEM or DEM is equal to 90 degree. So angle EDY is equal to angle DEM is equal to 90 degree, which is nothing but alternate interior angles, isn't it? So I can consider these two as alternate interior angles when this will be equal only if XY is parallel to MN. So hence proved. Let's move on to question number 23. We have an internal choice, so I will do both the questions. Okay, first let me start with the first question. Find A and B if sine A plus 2B is equal to root 3 by 2. So when sine will be root 3 by 2, that is sine 60 degree, isn't it? So I'm equating to sine 60. So sine 60 degree value is root 3 by 2. So now compare both the sides. So I can filter a plus 2b will be 60 degree, isn't it? Sine will be on both sides. So I just ignore it and write whatever is needed. Similarly, if I go for cos a plus b is given as 1 by 2. So when cos will be 1 by 2, at what degree? At cos 60 degree, isn't it? Hence, after comparing, I'm just filtering a plus b as 60 degree. So now I have two equation. Let me name it as 1 and 2. I'm going to solve it to find a and b. So a plus 2b is equal to 60 degree and a plus b is equal to 60 degree. So change the sign and cancel a or eliminate a. 2b minus b is b, that is equal to 0 degree. Okay, after getting b, I can substitute in any one of the equation. So I'm taking equation 1. So substitute b equal to 0 in equation 1. I will get a plus 2b equal to 60 degree. So a plus 2 times of 0 degree is equal to 60 degree, which is nothing but a is 60 degree. So I get the value of a and b, that is a is 60 degree and b is 0 degree. Let's do question number 23. We have an internal choice. So this is the second question of 23. Okay. So 1 plus cos A into 1 minus cos A is given as 3 by 4. I know this is written as A plus B into A minus B format. So the identity is A square minus B square, isn't it? So 1 plus cos A into 1 minus cos A is equal to 3 by 4, which is nothing but 1 square minus cos square as per the identity a square minus b square, which is 3 by 4. 1 square is 1 minus cos square a is equal to 3 by 4. So I'm taking cos square a to the other side and bringing 3 by 4 to the left hand side because cos square a is negative. So I'm taking to the right hand side to make it positive. So now if I take the LCM, I will get 1 by 4 is cos square a, isn't it? And cos a will be square crosses the equal sign will become square root, that is 1 by 4. So it is nothing but plus or minus 1 by 2. So cos A is plus or minus 1 by 2. Okay, but I need tan A. Tan A is nothing but sin A by cos A, isn't it? So I need to find sin A as well. So how can I find sin A? Again, I am coming to this equation. So let me name it as equation 1. Again, from equation 1, I know 1 square minus cos square is sine square. As per the identity, sine square a plus cos square a is 1, isn't it? So sine square a is nothing but 1 minus cos square a. So I can substitute instead of 1 minus cos square a as sine square a, that is equal to 3 by 4. So now take square to the other side. So sin a is equal to root of 3 by 4, which is nothing but plus or minus root 3. Square root of 4 will become 2 outside the square root. So sin a is equal to plus or minus root 3 by 2. Now find tan a. Tan a is equal to sin a by cos a. So sin a is plus or minus root 3 by 2 divided by plus or minus 1 by 2. So cancel 2 and 2. Okay, so it is nothing but plus or minus root 3. Question number 24. From an external point P, two tangents PA and PB are drawn to a circle with center O. So I know the tangent from the external point to the point of contact on the circle is going to be equal in length, isn't it? So PA is equal to PB. Now, at a point E on the circle, another tangent is drawn to intersect PA at C and PB at D respectively. You can see these 2 points, isn't it? So now think of C is also an external point. From C, there is a tangent CA touching the point of contact at A, right? So I know CA and CE will also be equal if you consider C as an external point and CA and CE are the tangent to the point of contact on the circle, isn't it? So this will be equal. Similarly, if you consider D as an external point, I know DB is equal to DE, isn't it? So now come to the next part of the question. If PA is 10 centimeter, so if the length of the tangent PA is 10 centimeter, PA is equal to PB, so that is also equal to 10 centimeter, isn't it? So now I need to find the perimeter of triangle PCD. So how I will find it? What is perimeter? Sum of the length of all three sides, we call it as perimeter, isn't it? The length of the outer boundary. So I'm going to add all the three sides PC plus CD plus DP. So here CD I'm splitting as since E is a point on CD. So I'm splitting CD as CE plus ED plus DP. So now change CE as CA. Okay, because we know, let it be equation 1. So from equation 1 we know CE as CA, right? So I'm replacing CE as CA. Similarly, from equation 2 I know ED is represented as BD or DB, right? Plus DP. So now you combine these two together. What is the length of PC plus CA? It is going to be the overall length of PA, right? Plus similarly BD plus DP will be PB. So we already know the length of P and PB which is given in the question, that is 10 plus 10, which is 20 centimeter. Okay, so this is going to be the perimeter of triangle PCD. Question number 25 as an internal choice. You can either choose the first question or the second question, but yes, let us do both the questions now. Okay, let's move on to the first question. In this question, I have drawn the rough figure. A rope by which a cow is tethered, that is tied, is increased from 16 meter to 23 meter. So here, think of the center is the where the cow is tied. Okay, with the radius length of the rope as 16 meter. So you know the cow can graze the field of this area for radius 16 meter, isn't it? So I'm shading that area. Now the radius has been increased to 23 meters, so which means it can graze extra area, that is the circle which I mentioned as a outer layer, isn't it? It can include this yellow space as well as the blank space, isn't it? But I need to find how much additional ground does it have to now to graze. So only this I have to find. Okay, because 23-meter rope will include that yellow zone, but I need what is the additional ground if the radius has been increased from 16 meter to 23 meter, which means I need to find the area of the shaded region. So what is the area of additional ground? So I know it is a shape as a circle, isn't it? So area of a circle is pi r square, and the bigger radius is capital R, okay, and the smaller radius is smaller. So R is capital R is 23 meter, that is the radius of the outer circle, square, minus pi, and small r is 16 meter, that is 16 square. Now take pi commonly outside, so you know it is 23 square minus 16 square. Either you can just square it 23 square, or you can just use the formula a square minus b square identity. I'm going to use that. Pi value is 22 by 7. So what is a square minus b square? A plus b into a minus b, right? So 23 plus 16 into 23 minus 16. Okay, as I said, you can either square and subtract it. That is also right. Okay, so keep 22 by 7 as it is. And what is 23 plus 16? It is going to be 39, and 23 minus 16 is going to be 7. So 39 times 7. So now I can cancel 7 and 7 because all are in multiplication. So finally I have 22 times 39. So I'm multiplying it. So the answer is going to be 858 meter square. So this is the area of the additional ground the cow can graze. So let us do the internal choice of question number 25. Find the area of unshaded region. Remember, they haven't asked the shaded region. Don't misconcept yourself and find the area of shaded region. They are asking to find the area of unshaded. That is a blank region. Okay, shown in the given figure. So this blank region, I can see four semicircles. So if I draw the diameter for each semicircle, it makes a square. So, what is area of unshaded region is made up of? Area of unshaded region is made up of area of one square, isn't it? Area of one square plus four semicircles. So, plus four times area of semicircle, isn't it? But do I know the side of smaller square? No, right? But I know the side of a bigger square. So now what I'm going to do, let me take the diameter of this semicircle as x. So which means the side of a square is going to be x, isn't it? So see here, the area of one square is going to be x times x, that is x square, and 4 times area of semicircle is, I know circle is pi r square, and area of semicircle will be pi r square by 2. Isn't it? Cancel it. So it is 2 pi r square, isn't it? And what is r here? So I need to find the radius first. From the figure, I know diameter of this semicircle is going to be the side of a small square, isn't it? So what is radius then? So diameter is equal to x, that is the side of a small square. So radius is x by 2. So first I need to determine x. So see here, from this center to the semicircle, we call it as radius. So the diameter is x, so radius is x by 2. Okay, and for this square, the side length is x, so from here to here it is x, isn't it? Again, from the center to the semicircle is radius, so it is x by 2. So if I add all this length, I will get x by 2 plus x by 2. Okay, x by 2 plus x by 2 is x, so I will get 2x, isn't it? So I know the length from the curve of the semicircle to the other end of the semicircle is going to be 2x, and on either side there is a width of 3 centimeter. So 2x plus 3 is going to be the bigger side of a square, that is 14 centimeter given in the figure, isn't it? So I'm equating to 14. Do you understand? So I am just equating this length to 14 centimeter. Okay, I'm adding all the required details. Okay, so 2x plus 6 is equal to 14. 2x equal to 14 minus 6, I'm transposing. So 2x equal to 8, x equal to 8 by 2, which is 4 centimeter. So the side length of a square is 4 centimeter. So what would be the radius? That is 4 by 2, right? So x by 2, so 4 by 2 is 2 centimeter. Now I have all the details. I know x is 4 centimeter, r is 2 centimeter. I'm going to substitute here. So x is 4 square plus 2 pi, r square is 2 square. So that is going to be 16 plus 2 square is 4, 4 times 2 is 8 pi. Okay, so 16 plus 8 pi centimeter square is your area of unshaded region, or you can substitute pi as 22 by 7 or 3.14. So you will get the approximation of the area as 41.12 centimeter square. So this is your area of unshaded region. So we have completed all the questions from section B, question number 21 to 25 with the internal choices of sample paper 3. If you have not seen my previous video on MCQs, please click the link here. If you have not subscribed to my channel, please do subscribe and click the bell icon so you will get the notification of the newly posted videos. The next video will be on section C from the sample paper 3. Keep practicing and wait for my next video. Thank you.